Hello, everyone. Today, we'll be diving into a groundbreaking technology trend that is transforming the future of transportation: AI in autonomous cars. This innovative advancement sits at the forefront of both the automotive and tech industries, marking a significant leap toward autonomous mobility. With progress in AI and machine learning, autonomous vehicles have the potential to revolutionize how we travel, enhancing road safety, reducing traffic congestion, and lowering carbon emissions. The importance of AI in this space can't be overstated, as it brings together automation, data-driven decision making, and transportation innovation in a powerful way. An autonomous car is a vehicle that can perceive its surroundings and can adjust its course and speed without human intervention. It does not require a human passenger to take control at any point, nor does a human need to be present in the vehicle. The terms autonomous and self-driving cars are very often used interchangeably. An autonomous car is capable of navigating any route that a conventional car would take and performing all the tasks of an experienced human driver. The Society of Automotive Engineers defines 6 levels of driving automation, ranging from level 0 to level 5. It starts with 0, where a driver is behind the wheel and in full control, to level 1 and 2, where a driver is aided by various automated warnings and safety features. Upon levels 3 and 4, the cars are self-driving under certain circumstances, but may require a human driver to take over. Lastly, level 5 represents an autonomous, self-driving car that does not require a human to operate the controls. Autonomous driving systems are generally structured in modules, consisting of layers for environmental perception, decision-making, and motion control. Autonomous cars rely on a combination of sensors, actuators, algorithms, machine learning, and to operate their systems. These cars perceive their surroundings using various sensors, which act as the eyes located across the vehicle. For example, radar sensors track the position of nearby vehicles, video cameras detect traffic lights, read road signs, and spot pedestrians, while LiDAR sensors emit light pulses to measure distances, identify lane boundaries. This data is processed in real time by advanced algorithm that charts the vehicle's path, makes predictive decisions based on vast amounts of data using advanced AI, and sends commands to the actuators, which control functions like acceleration, braking, and steering, enabling the cars to react instantaneously to dynamic road conditions. The development of autonomous driving technology is indeed dynamic, with numerous players from a variety of industries working to shape the future of self-driving vehicles. Here are some key companies involved. Aurora, a US-based startup, focuses on creating an autonomous driving platform that can be integrated with a wide range of vehicles. Its primary target market is freight transportation. Apollo Go, part of Baidu's Apollo autonomous driving platform, is leading the way in China's robotaxi market. It has launched autonomous ride-hailing services in several Chinese cities and is actively expanding its capabilities. Waymo focuses on developing a fully autonomous ride-hailing service using its fleet of self-driving vehicles. It is part of Alphabet, Google's parent company, and has been operational in cities like Phoenix, Arizona. Cruise, owned by General Motors, focuses on deploying all-electric autonomous vehicles for ride-hailing services in urban environments. Let's take a look at how autonomous vehicles are being applied across various industries. Companies like Waymo, Baidu, Apollo have introduced driverless taxis, or robotaxi, in cities such as San Francisco and Wuhan. These robotaxis aim to reduce the need for human drivers, making transportation more efficient, accessible, convenient, and safer. For example, Baidu has introduced autonomous rides to and from Wuhan Airport via their driverless taxi Apollo Go. In logistics and delivery, self-driving vehicles are being utilized for automated delivery services. These vehicles enable safe, contactless delivery of goods to customers, streamlining the entire delivery process. For examples, Walmart has partnered with General Motors' self-driving cars Cruise to do deliveries in certain areas in Arizona, US. These applications are not just transforming the automotive industry, but are also driving major changes in logistics, e-commerce, and public transportation. The future of mobility is truly being redefined. As one of the applications, robotaxis offer several advantages over traditional taxis. First, they significantly reduce operating costs. Since there's no need for human drivers, labor costs drop, making transportation more affordable. They also offer increased efficiency. Robotaxis can optimize routes and minimize idle times, resulting in faster, more efficient rides with fewer delays caused by human error. In terms of safety, robotaxis utilize advanced sensors and AI-driven decision-making, which helps to reduce accidents related to human factors like distracted driving or fatigue. Another major benefit robotaxis provides is 24/7 availability. They can operate continuously without breaks, especially in areas where transportation options are limited. As many robotaxis are electric, they also help reduce greenhouse gas emissions, promoting cleaner and more sustainable transportation solutions. Finally, robotaxis offer mobility solutions for people who are unable to drive, such as the elderly, disabled individuals, or those without access to a personal vehicle. Here's a video I took while ordering Baidu's Apollo Go taxi in my hometown Wuhan this summer.
看车牌，那就这一辆108。OK， 你要开是吧？天哪，还有刷脸呢，先坐进去。你要加进来要不然先把它开起来。
Equipped with all the aforementioned advantages, autonomous cars present various opportunities in the future. For example, autonomous cars will be a critical element in the development of smart, connected urban areas. As cities continue to grow, managing traffic and transportation is becoming increasingly complex. Self-driving cars will help solve this problem by enabling more efficient public transport systems, allowing us to optimize routes in real time and reduce delays. We'll see a significant reduction in traffic congestion, which is one of the biggest challenges faced by modern cities today. Imagine a future where traffic flows smoothly and the need for vast parking spaces diminishes, thanks to self-driving vehicles that can keep moving and be shared by multiple users. Additionally, companies can innovate new business models, such as mobility as a service, where customers can subscribe to autonomous transportation services similar to ride-sharing apps. Although autonomous cars hold great promise, they still face significant challenges, from navigating regulatory hurdles, addressing ethical concerns, overcoming technological limitations, and building public trust. First and foremost, the current laws and regulations are not yet fully equipped to handle the widespread deployment of driverless vehicles. Governments need to establish clear standards for safety, liability in the event of accidents. For example, who is responsible when a driverless car gets into an accident? The manufacturer, the software developer, or the owner of the vehicle? These are the kinds of legal questions that need to be answered before we can see mass adoption. From ethical perspective, autonomous cars must be programmed to make difficult decisions in life or death scenarios. For example, if a driverless car faces an unavoidable accident, how does it decide whether to protect the passengers inside or the pedestrians outside? Secondly, while the technology behind autonomous vehicles is advancing rapidly, there are still technological limitations. Autonomous vehicles rely on sensors like LiDAR, radar, and cameras, but these systems can sometimes fail under certain conditions, such as poor lighting. The system's effectiveness can also be diminished when sensors or lane markings are covered by snow or other heavy precipitation. Moreover, achieving full autonomy requires a massive amount of data processing in real time, which puts a huge demand on computing power. One of the less technical but equally important challenges is public trust and acceptance. Many people are still skeptical or fearful of riding in a car that doesn't have a human driver. High-profile accidents involving autonomous vehicles have raised concerns about their safety, and building consumer confidence will take time and effort. Overcoming this challenge will require not just technological improvements, but also transparency and education. People need to understand how autonomous vehicles work and why they can be trusted. Looking ahead, the future of autonomous cars is promising. As AI algorithms become more sophisticated and sensors and processing power improve, fully autonomous vehicles may become mainstream in the next decade. They have the potential to significantly reduce road accidents due to human errors, which currently cause 1.3 million deaths annually. Moreover, autonomous cars will likely operate as shared vehicles, reducing the need for private car ownership. It will also revolutionize logistics by improving delivery speed, operational efficiency, and fuel use. Additionally, it can also minimize the need for parking spaces and ease traffic congestion, improving walkability, livability, and reducing noise pollution. Lastly, with autonomous technology managing speed limits and parking, drivers can save money and avoid frustrations associated with tickets and penalties. In conclusion, autonomous cars offer significant advantages, including drastically reducing road accidents by eliminating human error, enhancing safety through advanced technology. Their potential to promote shared vehicle usage can lower costs, ease traffic congestion, and free up urban parking space. Additionally, these vehicles are set to revolutionize logistics by improving delivery efficiency and reducing operational costs. As they contribute to lower greenhouse gas emissions, autonomous cars will play a crucial role in the development of smart cities, enhancing urban livability. Ultimately, as technology advances and regulations evolve, autonomous vehicles promise a safer, cleaner, and more efficient future for transportation.